Hi, everyone. Thank you so much for being able to join us today. This is the Force Crash Course. We are going to have the first part of a multi-part series where we kind of boot camp y'all into the Platform Developer 1 certification. So I'm Saman. I'm a software engineer based out of Dallas, Texas. I recently graduated from the University of Texas at Dallas, with my bachelor's degree in software engineering. And I currently hold 5 Salesforce certifications, and I'm still counting those. I'm hoping to get the Platform Developer 2 certification here real soon. I started off, the very first certification I got was my Platform Developer 1, kind of jumped headfirst into that one. And then I went on with the goal in mind of getting the Application Architect certification. So I worked towards and received the Platform App Builder, the Sharing and Visibility Designer, and the one that I thought was the most challenging, which was the Data Architecture and Management Designer. So motivation behind this course, why I thought to put it together and why I wanted some people to get behind it with me, really mostly stems out of all the uncertainty coming around the COVID-19 cases going on all across the world. I've been seeing on my LinkedIn, especially, as well as some on my Twitter, about people either losing their jobs or being scared that they're going to be out of work soon. To my excitement for the platform, I wanted to put something together where we could all expand our skill sets and get excited about Salesforce and really give us all an opportunity to become more T-shaped with the Salesforce platform and learn more about it. I really do think Salesforce is a great platform. One thing that I really enjoy about it is that I think it gives us as developers and people in the technology team to really promote IT agility and help promote business value quickly to our business users and the end users in general. And I'm really excited to share some of the work that goes into that with y'all through this bootcamp. So about the course, we will be following the official guide that Salesforce provides. And what that means is we're gonna take a look at that guide, break down every section by section into multiple videos. And obviously, since y'all are on the call, this is gonna be a live classroom style lecture. So please take advantage of it. At any time you have a question, please unmute your mics and jump in and ask whatever you have, any clarification questions, because I'm sure if at least one person has a question, there's at least a few more in the room that have the same question. If you're not able to join us live in the course, I will make these videos available on YouTube right after the course is published. And I'll also be able to, throughout the course, provide my tips and best practices throughout the course. We do have a LinkedIn group, which a lot of people have joined so far. It's the Force Crash Course PD1 Bootcamp LinkedIn group. It should be available for you to search, but if not, I'll also post the link to the group below in the comments of this YouTube video and on the LinkedIn group to share with your friends or any coworkers that might also be interested in the course. And of course, since it's a LinkedIn course, please feel free to network in there, post questions, post any opportunities, and really take full advantage of all the Salesforce professionals that are in the LinkedIn group along with you. I'm sure most of you are already familiar with Trailhead. I think it's a fantastic resource for self-paced learning. That is kind of the primary way that I became familiar with Salesforce and took on a bit of a heuristic approach to go and learn through the different modules that they provide. I would really encourage everyone to sign up for Trailhead and create a playground on there. It is a wonderful place where you can work on different modules. They have different projects for you, all kind of aimed as a free way to learn about the Salesforce platform. I do provide complimentary trail mixes at the end of each PowerPoint. And really the goal of this is that as we go through the course material, Salesforce does a really good job through some of these trail mixes in applying that. And as opposed to me spending time on the video to go through some of those, I'll provide those complimentary trail mixes and we'll be able to, you'll be able to, at the end, go through and just work on what you want to work on at your own pace. So the exam, this is straight out of the documentation that Salesforce provides for this developer certification. It's a 60 question multiple choice or multiple select question exam. So what that means is some of the questions, it'll say there's one right answer, and some of them it'll tell you there's 2 or 3 right answers, and you'll have to pick the right amount. You will need to get all the answers for that question correct in order to get all the points. And you get 110 minutes for the exam. So that's a little bit under 2 minutes per question. The passing score is 62%, and the exam does cost $200. And if you do not pass the first time around, you'll have a second shot and you can pay a reduced fee of $100 for the retake. There are two ways to take the exam. The first one is through a proctored on-site center. So Web Assessor, which is the company that works with Salesforce to deliver this exam, has different on-site testing centers that they partner with, and you can go in there in person, use their computers to take the exam. Alternatively, you can use your own computer as well and take the exam in your own home through the online proctored environment. And due to all the COVID-19 that are going on in the world, Web Assessor and Salesforce have kind of took a notch down on some of their requirements for taking this exam. Previously, you needed a external webcam. So if you had your internal webcam built into your laptop, you wouldn't be able to use that. You'd have to go out and buy an external one. But thankfully, they've kind of laxed those rules a little bit because of this epidemic. So that could be something to take advantage of. You can't unfortunately bring any materials into the exam with you, so no hard copies of anything that you can reference, and there are no prerequisites for this exam. So there are 5 parts to this exam. The first one, which is what this lecture will be over about, is Salesforce Fundamentals. It really covers describing the considerations when developing in a multi-tenant environment, being able to define what that means, what a multi-tenant environment is, and weighing out some of the pros and cons. It'll also dive deep into MVC architecture and the Lightning component framework that Salesforce has built, and how to use those to build applications with both declarative and programmatic tools that Salesforce provides. And throughout the exam, they'll also be questioning you on identifying common use cases and opportunities to use declarative tools versus the programmatic tools that Salesforce provides. The next video will be over data modeling and management. That covers 13% of your exam. This is all about identifying whether, if Salesforce gives you a paragraph about some customer use case scenario, will you be able to create a data model out of it? Are you able to identify what objects are needed, what fields are needed in those objects, and what relationships to create between those objects? And then also in the next part of it, being able to define the capabilities, again, some of the pros and cons of the different relationships you create, and the implications that come along with them, as well as kind of diving into data exporting and importing through their different tools and any other third-party solutions that might be available, and identifying when a good opportunity is to use formula fields or roll-up summary fields, and the different situations you can use them in. The biggest chunk of the exam is this, the process automation and logic. This part of the course I will break down into several different videos just because I want everything to be centralized in its own, so it'll be easier for us to focus on each individual topic. So we'll more than likely have one video over all the declarative processes that Salesforce provides. And then for those of you that aren't familiar with programmatic coding at all, we'll have a separate course that just talks about how to code and how to code in Apex specifically. And then we'll have follow-up videos about how to integrate that custom code that we wrote with the Salesforce search language, the query language, and then how to do DMLs using Apex as well. Following that, talking about the different governor limits and Apex transaction limits that Salesforce provides, trying to figure out why that is even in there to begin with and how we can work around it as developers, and how to explain the rest of the relationships between the execution order of Salesforce, how errors are handled, and how to promote security on the platform. Testing, debugging, and deployment. Some of the testing will go hand in hand what we learn in the process automation portion of the lecture, so expect for some of that to be integrated with that. But this is all about, if you're not familiar with unit testing in a IT environment, basically this is the code that you write to test the code that you're delivering to your business partner. So we're going to learn how to execute that code for triggers, controllers, classes in Apex, how to execute that, either an anonymous Apex or how to execute unit tests. And then we're also going to explore the different developer tools that Salesforce makes available to us, like Salesforce DX, the CLI, the developer console, and a couple other ways, and how we can really leverage those the best we can as Salesforce developers, as well as kind of diving into how to do debugging, how to monitor flows, processes. That will, again, probably cover mostly in this section as well as kind of going over the different environments, requirements, and the different license types that are required for Salesforce. The last section is the user interface. This one will be going over visual force pages, the Lightning component framework, visual flows, and Lightning flows, and everything else that you could imagine would be packaged up into a UI course that a Salesforce developer would need to be focused on. Okay, so any questions about the exam before we get started on one of the sections?
Nope.
No? Okay, great. So section 1, Salesforce Fundamentals. Let's get started with this one. So the first subtopic that Salesforce wants you to know about for this exam is whether or not you can describe the considerations when developing in a multi-tenant environment. So let's first talk about what a tenant even is before we start talking about multi versus single tenants. A tenant is really just a group of users or a group of software applications that share hardware through an underlying piece of software. So we have our server dedicated, and a tenant determines whether there are multiple apps that are using that one single source of hardware or there are multiple. So in a single tenant environment, we have a single application or a single group of users using up that server, using up that hardware. So they don't have another app or another group of users that's trying to share resources with them. Versus a multi-tenant environment is one where multiple apps and multiple different groups of users are using the same server, the same memory, the same CPU, network controllers, and everything else that comes along with a hardware configuration. And the system, the server, is responsible for dynamically allocating all these different resources to those different sets of apps and groups and users. And that's what Salesforce does for us. And that's what makes it a multi-tenant environment. Advantages and disadvantages of the single tenant environment. Why does Salesforce use them? Why don't they use them? The advantages right off the bat are you get more control over system resources because you don't need to share them with anyone. And what I mean by this is if you have hardware in a multi-tenant environment, you need to be able to make it a little more generalized because you don't always know what apps might be running on it, and different apps have different needs. So because of that, you need a more general suite of hardware and software that runs on that hardware. And that's something that you can avoid with a single tenant environment because you know exactly the types of resources that are labor intensive for that piece of software, and you can accommodate that with your hardware. It gives you an opportunity to do greater customization because of that, and you avoid this thing called a noisy neighbor syndrome, which we'll talk about a little bit later, but just to give a peek at it, this is basically saying, is there another app or is there another group of users who are really taking up a lot of resources that prevent me from doing what I need to do in my application? Some of the disadvantages, although, that come with single tenant environments is that there's no cost sharing between the apps. Like I mentioned before, each app is sitting on its own server. Different apps might be used at different points of the day. So if you have a time period where the app isn't being used very much by your users, that server is just sitting idle, but you're still paying the maximum amount of price for it. Versus in a multi-tenant environment, since the different apps can run at different times, you're really getting the full use out of that server that you're paying for. And they are also less efficient because, like I said, they're not running at full capacity. Switching gears into multi-tenant pros and cons, biggest benefit is that there is going to be shared costs between all the different apps. And you also have simplified hosting. Especially with Salesforce, the hardware is all managed by them. So as a developer, you don't need to worry about any hardware decisions at all. You can just jump straight in, I should say, into your implementation. Fortunately, there are some negatives with a multi-tenant environment as well. Outages can impact all the apps on that suite of hardware. So if Salesforce has set up a server for you and others to build your applications on, if that server goes down, so do all the applications that run on that server. Thankfully, Salesforce.com does mitigate that through some of the redundancy that I would assume is proprietary on their side. And one of the cons as well is the noisy neighbor syndrome that I mentioned earlier. And that is when other apps may dominate the system resources that provide other apps that are equally important from running and being able to do what they were built to do. And thankfully, Salesforce does mitigate this by the concept of governor limits, which we got a hint at when we were going over the process and automation section, but we'll be able to dive deeper and explain what some of these governor limits are. And at least we have this as a background to understand why they're important. So what does this all mean for you as a Salesforce developer? Like I said, there are no need for you to be worried about networks, your operating system, the databases, the servers, or any other piece of hardware that your software is going to run on. There's no worrying about missing jar files in your Java project. You don't need to be worried about installing Red Hat versus Linux on your operating system for the server you're standing up. And you don't need to wonder which load balancer to use. Instead, you can just design your data model, implement the business logic, and then test your code and deploy the application to your users. So before I keep going, I want to take a break and talk about some of the different terminology within Salesforce, since I do see these commonly interchanged, organization and instance, and I just want to clarify what Salesforce has defined these two different pieces of terminology as. First, an organization, that is your unique Salesforce.com data and metadata. These are all the data, the fields, the code, the processes, the reports, anything that you build, all held together and packaged as one. So if Google, for example, has a Salesforce instance, excuse me, a Salesforce theme, see, I did it myself. If Google has a organization or an environment on Salesforce, whatever they built their application to do, it's packaged all up as one organization called maybe google.salesforce.com or whatever they named their org. But their org sits on an instance, that server that Salesforce stands up for Google and others. So for all we know, Google's organization of Salesforce could be on the same instance as a small mom and pop shop that was stood up to have some sort of CRM functionality. And an app, there could be multiple apps within an organization. And an app, all it is, it's a collection of interrelated functionality. It's the metadata in your org acting as one unit. Any questions about this or any other part of the course that I've gone over so far? No?
I have a quick question.
Yeah, what's that?
When you talked about single tenant versus multi-tenant, I'm a little bit confused about how single tenant can be less efficient if it's not having to share any resources with other tenants. Can you talk a little bit more about that?
Yeah, I can. Thanks for asking. So what I mean by that is whenever you stand up a server, you're usually buying a certain amount of hardware along with it. You're buying a certain amount of memory along with it as well. And really, whenever you're buying all these different resources, you're assuming for the worst case scenario of what if all my users all come in on once? I want to be able to handle that. Well, unfortunately, all your users aren't going to be using the application all at one time. So a lot of those resources that you paid for are just sitting there idle and your computer is not being utilized to its maximum potential. But if you are able to put different organizations and different environments onto one single server, the way I was talking about with Google's organization running on the same instance as some small mom and pop CRM stand-up, they'll be able to both utilize the server at the same time. And since ideally with these governor limits and everything else that Salesforce has built in, they won't overrun the server, but they'll be able to get more out of the server hardware because both apps are running in there. Did that clarify it at all?
Yeah, it did. Thank you.
Okay, cool. Any other questions?
The app that at the bottom of the slide, so would an installed package be an example of an app like that?
Yeah, you could definitely go to the the App Exchange and download or buy a managed package that comes in as an app.
So when you say that multiple apps are sharing resources on the same server, right, on the same instance, those are that would be one example.
Yeah, exactly. And you would put that app inside of your organization. So if you could think about, maybe I should have organized this in a different way because there are multiple apps that can live inside a environment or an org, but then with multiple orgs also live inside one instance.
Right. Okay.
Yeah, but if you, yeah, absolutely. And if you had your own org set up through Salesforce, you could get a managed package app installed on that org, and you could also build your own complementary set of software as its own separate app and have both those apps living on the org, whether they're complementary to each other or not.
Okay, got it.
Are all Salesforce instances considered multi-tenant? Is there a scenario wherein it is a single tenant?
As far as I know, that is the standard way of doing it. I'm sure if you have a large data volume and a large set of users, perhaps you could call Salesforce and have them set up a unique situation for you based off your need. Org versus instance, it might still be a little bit confusing. One way that we can help think about it along with things that we're a little more familiar with is we can think about a Salesforce.com org as a house and a Salesforce.com instance as your neighborhood. So we can all go out and get a base model house from Salesforce and customize it for our own needs. We can build our own architecture styles off it, do our own interior design, do our own lawn work, anything we want. That house is ours. We can customize it however we want for whatever use case we want. But that house is still going to be plotted on the same neighborhood as everyone else's houses. But we can still do whatever we want with our own house. The city of Salesforce builds our roads, they build our sewage pipes, our water lines, our network cables, our electric cables, they stand up the house for us, we're good. We no need to worry about any of that. But if for whatever reason the neighborhood gets hit by a tornado or some other natural event, all of the homeowners in that neighborhood are going to be equally affected. But people in the surrounding neighborhoods are going to be untouched, again, because they're sitting on a different Salesforce instance, a whole different. So now we can dive into the second part of this first part, Salesforce Fundamentals, and that is our ability to understand the different design frameworks, MVC being a common framework that's used in many different development applications, as well as the one that's more unique to Salesforce, which is the Lightning Component Framework. And then we can talk about a little bit how to build those applications using declarative and programmatic tools. So MVC stands for Model View Controller. It's a fundamental software design pattern that divides a related program logic into 3 different interconnected elements and then defines their relationship. This is really the first framework that a lot of computer science and software engineering students study in their degree programs, and it can be applied to Salesforce. So the model is a central component of the pattern. It's the dynamic data structure, and it's completely independent of the user interface. You can think about the model like your data model. This is how you define your S objects, the fields in that S object, and the relationships between them. The view is what your user sees. It's a representation of what your data model. Since a lot of users probably don't want to be looking at a database backend, they want their information to be displayed to them in a rather pretty way. That's what the view is for. And finally, the piece that connects the two is the controller. This converts what your user can input in the view and then turns that into commands to grab values from the model, manipulate some of the data in the model, and send it back to the view. Here's a sequence diagram that illustrates what an MVC really is all about. Let's say on your view, there's a button. Whenever that button is pressed, it creates an event. That event translates all the information that's a part of it onto a controller, which we can think about if you're writing custom code, the controller would be your Apex code. That controller figures out what needs to be done. If it needs to do any calculations first, it does it. And then it goes on to the model, which is the database or your S object, grabs whatever values it needs. It might compute some things again, and then it returns it back to the view. So it's really just 3 distinct pieces of logic. Try to wrap this up before our 40-minute. Okay. So what are some of the benefits of this? It allows for us to do simultaneous development. So since these are all 3 different pieces of code, multiple developers can work on each one simultaneously. It gives us an opportunity to have high cohesion between the different pieces, the different elements, I should say. And it gives us a way to do loose coupling. So that tied back into the simultaneous development. These are not highly dependent on each other. They all have their individual responsibilities. So there's loose coupling there. And there's also a ease of modification. Since we've separated out the responsibilities, if someone comes in maybe 3 months from now, 5 years from now, wants to make some sort of change, they know exactly where to go to make a change on either the controller, the view, or the model. And this also gives us an opportunity to create multiple views. So if we had a different group of users who wanted to see the data presented in a slightly different way, we can do that with multiple views. This is a little bit different from Salesforce Lightning, which is a framework that Salesforce has built to allow us to build responsive applications for any device. It is done through the Lightning Component Framework, which is a UI framework for developing single-page applications for mobile and desktop devices. And Salesforce gives us 2 programming models to create our own Lightning components. That is through Lightning Web Components and then the legacy piece of software called Aura Components. So Lightning Web Components, why did Salesforce go out and make a whole new version of these Lightning components, and why did they switch from Aura? Well, some would say it's easier to learn. Since there's no Aura framework there as an abstraction level, you can really jump straight into some vanilla JavaScript and get to building what you need to build without relying on the Aura framework. Because there's no Aura framework that needs to come in and load some information for us first, we get some better performance out of it, which means our web pages get to load a little bit faster and communicate to the server a little bit faster. And there's more of a focus on web standards. And you can think about this as more of a transferable skill, like I've mentioned in the next bullet point, where if you work on other web application frameworks like React.js or Angular, you'll be able to translate those skills over to Lightning Web Components. That I would imagine provides Salesforce an opportunity to expand its technology portfolio to other developers with other skill sets. So what is the benefit that both Lightning Web Components and Aura gives us? That would be SPAs, single page application. What this is a web application that dynamically loads parts of the web page instead of loading the entire thing at once. So if you've ever gone on any website and you've noticed some parts of the website load before other parts do and it doesn't all load at once, that's because that website is more than likely a single page application. What this does is as soon as the user first hits the web page, it initially brings in all the required elements like all the HTML, CSS, and JavaScript. And after that, the page does not reload or transfer control to another web page or another URL at all. It's able to do it all dynamically itself. And ultimately what this does for the end user experience is provides a faster and more seamless transition throughout their web application. Does this trip anyone up, or are we still good?
Can you give an example in the context of like a Lightning web page?
Yeah, so let me tie it to maybe different websites that y'all are already familiar with. So if we go to like either LinkedIn or Facebook.com and we load either of those websites, the very first thing that usually loads is our feed. So all the posts that other people make. Once that loads, or while that's loading, we'll see other parts of the web page load, like the messaging portion of Facebook or the messaging portion of LinkedIn, and maybe any new requests or notifications that are coming in. And I guess what happens is LinkedIn and Facebook, internally, they decide the priority of when to show that information, and they're able to show certain information before others because they're not mutually independent of each other. So because of that, they all load at different times. Or another example, if you're ever going through a form where you're going through multiple pages and filling out different answers to different questions on that form, you might notice that your entire form doesn't reload and it doesn't say like page 1, page 2, page 3. The URL stays the same. And because of that, you don't need to wait for the entire page to load with a new set of questions. Via JavaScript, it's able to go pull those new set of questions and really quickly deliver them on your web page.
So in Salesforce, could it be then, let's say, the details of the record load first and related list second or something like that?
Yeah, exactly. And if you've ever loaded like a Salesforce on Salesforce Lightning, if you've ever loaded one of the record pages or even a list view, you'll be able to kind of get a hint of that as well and see certain elements loading before others.
Okay, thank you.
Okay, getting towards the end there, given a scenario, identify the common use cases for declarative versus programmatic customization. Obviously, it's a little hard to dive deep into this right now because we haven't gone over any declarative versus programmatic customizations. But as we go through the course, it'll become a little more clear. So we'll learn about things like process builders, workflow rules, triggers, and be able to identify when to use which one, what are some of the limitations around them. And given the use case that Salesforce provides to us on the exam, we'll be able to analyze that and decide what different element to use. So we'll learn about process builders, formula fields, triggers, validation rules versus triggers, roll-up summary fields versus triggers, flows versus Lightning Web Components or Aura. And then ultimately, should we use something that Salesforce provides to us out of the box, or should we rely on something from the App Exchange to bring in an app? And really, you can see the theme of this is really, should we use something that Salesforce provides to us out of the box, or can we use some of the resources it gives us and build our own set of tools? So as I mentioned, there is a Trailmix for this section. I will provide this in the comments below, but it first starts us off with Salesforce Platform basics, and then talking about the Lightning experience basics, and then just giving a high level about CRM and really the core functionality of Salesforce. So please feel free to Once I post that link, jump in here and explore some of these modules that will help solidify some of the things that we learned in this course, and will ultimately help you be more prepared for the next course where we start talking about data modeling and management. And I will also be posting another link on LinkedIn as well as below in the comments for a feedback form. So I really encourage y'all, if you have any opinions about the course or maybe some topics I didn't cover as in-depthly as needed to, or I need to reformat anything, please let me know so I can make this course better for everyone. So I'll provide that, and please, if you have any comments, provide them.